In question 1, we have to find the set of values of k for which the curve y equals to kx square minus 3x and the line y equals to x minus k do not meet. Now, as we are talking about an unknown constant and there's a quadratic equation, so we will be using the discriminant. And as the line and the curve are not meeting, it means it will be less than 0. So in the first step, we'll equate the equation of the curve, which is kx square minus 3x, with the equation of the line, which is x minus k. Bringing the x minus k on the left-hand side, this will become kx square minus x minus 3x plus k equals to 0. Taking x common over here, so this will become minus 1. So minus x minus 3x, so that will become minus 4x plus k. Now the coefficient of x square is k, so a will be equals to k. The coefficient of x is minus 4 and the coefficient of the constant term is k, so c will be equals to k. So applying b squared minus 4ac, this will become minus 4 whole squared minus 4 into a into c, and that will be less than 0. So this will become 16 minus 4k squared will be less than 0. Now we can factorize this, and this can be written as, so we can first divide this by 4. So this will become 4 minus k squared less than 0. And factorizing this, this will become 2 minus k and 2 plus k as less than 0. Now, once we have these values of k, we have to give the correct inequality sign with them. So making the points on a graph. So one of the values is plus 2 and one of the values is minus 2. Now, b square minus 4ac has to be less than 0, which means it will be a negative. So this curve will be negative between these two values of k. So the values of k will be k greater than. So this will become k will be, okay, so there'll be one difference over here, as we had a negative k squared over here. So you would have to make it first of all positive. So this will, if we may write it as 4k squared minus 16, this would have become greater than 0. And then dividing this by 4, this will become k squared minus 4 greater than 0. And this will become k minus 2 and k plus 2 as greater than 0. Now, when you're doing an inequality equation, let's say we know that if 9 is greater than 8, so minus 9 will be less than minus 8. So if you're changing the sign of the constant we are trying to find, this sign switches around. So this will become k minus 2 and k plus 2 is greater than 0. Now, as this is now greater than 0, so this curve will be positive or greater than 0 when we are going towards the right from 2 and to the left from minus 2. So the values of k will be, so k will be greater than 2 and k will be less than minus 2. In question 2, the coefficient of x cube in expansion of 1 minus 3x power 6 and 1 plus ax power 5 is 100. We have to find the value of the constant a. Now, if you have an expression of the form 1 plus b to the power n, the expansion is 1 plus nc1 b to the power 1 plus nc2 b to the power 2 plus nc3 b to the power 3 and so on. Now, one of the expressions is 1 minus 3x to the power 6. As we're talking about the coefficient of x cube, so we'll have to use the term nc3 b to the power 3 to find the term in x cube, as b is x to the power 1. So we'll write 6c3 and this will become minus 3x to the power 3. Now 6c3, if we substitute this in the calculator, so 6c3, so 6c, just a second, so we'll have to substitute the c sign over here. So this will become 6c3, that is equals to 20. So this will become 20 multiplied by minus 27x cube. And for the second expression, which is 1 plus ax to the power 5, so this will become 1 plus ax to the power 5. So again, we'll use 5c3 ax to the power 3. So 5c3, if we substitute this in the calculator, so 5c3 is 10. So this will become 10 a cube x cube. Now we know that the coefficient of x cube will be 100. So we can first multiply 20 and minus 27. So 20 times minus 27, that's equals to minus 540. So that will become minus 540x cube. So this is equals to minus 540x cube. And this is 10a cube. So this will be minus 540x cube plus 10a cube x cube. And that will be equals to 100x cube. So now comparing the coefficients, if we take x cube common out, this will become minus 540 plus 10a cube is equals to 100 x cube. Cancelling out the x cube, we'll get minus 540 plus 10a cube is equals to 100. Simplifying this will become 10a cube is equals to 100 plus 540, which is 640. So a cube will be equals to 640 divided by 10, which is 64, and cube root of 64. So a will be the cube root of 64. The value of a will be positive 4. In question 3, showing all necessary working, we have to solve the equation 6 sine square minus 5 cos square equals to 2 sine square plus cos squared. So in the first step, we can first simplify the equation. The equation is 6 sine square minus 5 cos squared equals to 2 sine squared plus cos squared. So bringing the sine squared on one side, this will become 6 sine squared minus 2 sine squared, and the cos squared on one side, so this will become cos squared plus 5 cos squared. We'll get 4 sine squared is equals to 6 cos squared. Now bringing sine squared and cos squared on one side, as we know that if as tan x is sine x upon cos x, so sine square upon cos square will become tan squared. So writing it as sine squared upon cos squared is equals to 6 upon 4. So we can write this as tan squared is equals to, so tan squared x will be equals to 3 upon 2. So in the first step, we can get rid of the squared sign by taking the square root of 3 upon 2. Now we can find the basic angle first. So the basic angle alpha will be equals to tan inverse of square root of 3 upon 2. So shift tan inverse and taking the square root of 3 upon 2 and keeping the calculator in the degree mode, as the range of x is from 0 to 360. So this will be equals to, okay, just okay. So we have to do shift tan first. Shift tan inverse of, this is 3 upon 2. So the answer is, the basic angle is 50.76. So we have 50.768 degrees as the basic angle. Now to find the values of x, we can make the basic angle 50.768 in the quadrants. Now, as it is a square root sign, it means we can have both the positive and negative values for tan. So we'll make this the basic angle 50.768 in all the 4 quadrants. So we'll make it in all of these quadrants, and the basic angle is always with the positive x-axis. So this is 50.76. This is also 50.76. This is 50.76. And this angle is also 50.768. So the first angle for x will be 50.768. So x, the first value will be 50.768. The second value will be 180 minus 50.76. So 180 minus 50.76, that is equals to 129.24. The third angle will be 180 plus 50.76. So 180 plus 50.76, that's equals to 230.76. And the last value will be, so we'll be taking it from the positive x-axis anti-clockwise. So this will become 360 minus, so this will be 360 minus 50.76. So the last angle will be 309.24. Once we have these 4 values, we can write the final answer to 1 decimal place, as angles have to be given to 1 decimal place. So this will become 50.8. The second angle will be 129.2 degrees. The third angle will be 230.8. And the last angle will be 309.2 degrees. In question 4, the function f is such that f of x equals to x cubed minus 3x squared minus 9x plus 2 for x greater than n, where n is an integer. It is given that f is an increasing function. We have to find the least possible value of n. Now, if you're talking about an increasing function, it means that the dy dx will be greater than 0. So in the first step, finding the derivative of the function, so that will be f dash of x, that will become 3x squared. So 3 will multiply with the coefficient 1 and the power will decrease by 1. Differentiating 3x squared, that will become a 6x, and differentiating 9x, that will become a 9. 2 will become a 0. So this will be the derivative. Now we'll write 3x squared minus 6x minus 9 as greater than 0. Dividing the equation by 3, we'll get x squared minus 2x minus 3 greater than 0. And factorizing this, so we need minus 2 when we add the two numbers and minus 3 when we multiply. So we can take that as x minus 3 and x plus 1 as greater than 0. Now, we need the least possible value of n. So the first step, what we can do is we can make these 2 points on the graph. So this is x3 and this is x minus 1. Now for this to be greater than 0, x has to be greater than 3 and x has to be less than minus 1. Now, as in the question suggested that x has to be greater than n, so the only possible value we can take over here is x will be greater than 3, as x cannot be greater than minus 1. So it cannot be possible between these two values. So the function can be increasing when it is only greater than 3 and less than minus 1, which means that the only possible answer will be x greater than 3. In question 5, the diagram shows a major arc AB of a circle with center O and radius 6. Point C and D on OA and OB respectively are such that the line AB is a tangent at E to the arc CED of a smaller circle also with center O. Angle COD is equals to 1.8 radians. In part 1, we have to show that the radius of the arc CED is 3.73, correct to three significant figures. Now, as we have to show that the radius of the arc CED is 3.73, it means we have to show that this length is equal to 3.73. Now, OB has a length of 6, we already know this. And as this whole angle is 1.8 and this length is also 6 OA, so it means that this is an isosceles triangle. So when we make a line from O till E, this will be a right angle and this angle will divide in two, so this will become 0.9. Now, as we already have this angle, to find the length of OE, we can use adjacent over hypotenuse, which is cos. So we can write it as cos of 0.9 will be equals to OE upon the length of OB, which is 6. So OE will be equals to 6 multiplied by cos of 0.9. So this will become 6 into cos of 0.9, which is 3.7. So first writing 6 multiplied by cos of 0.9. So the length of OE will be equals to 3.729 centimeters. And as we have to give it to two decimal place or three significant figures, so the length of OE will write it as 3.73 centimeters. In part 2, we have to find the area of the shaded region. Now, we already have this angle 1.8 for the small sector. To find the angle of this bigger sector over here, so we know that the total angle is 2 pi. So we can write that in part 2, first of all, we can write that the angle COD will be equals to 360 minus the angle, or 2 pi minus 1.8 radians. Now, once we have this angle, the area of the sector, we can call it OAB. So the area of sector OAB, or the larger sector, is basically given by the formula half r squared theta. The radius for the bigger sector is given as 6 centimeters. So this will become half into 6 squared, and theta will be 2 pi minus 1.8 radians. So substituting this in the calculator, so this is 2 pi minus 1.8 and multiplying it by 36 and then dividing this by 2. So this will become 80.8 80.697 centimeters squared. So the area of the larger sector is 80.697 centimeters squared. Now finding the area of the smaller sector. So the area of sector, we can call that sector as ODC. So the area of sector ODC will be given by half into r squared. Now we already have the length of the radius, which was 3.73. So this will become 1 upon 2 into 3.73 whole squared multiplied by the angle, which was 1.8. So 3.73 whole squared and then multiplying, so 3.73 whole squared and multiplying this by 1.8 and dividing by 2. So this will become 12.52 centimeters squared. So the total area of the shaded region will be equals to, so the total area will be the area of the larger sector, which is 80.697 plus 12.52. Adding these two up, we'll get 12.52 plus 80.697. This will be 93.217. So this will be equals to 93.217. And as we have to give our answer to three significant figures, so the final answer will be 93.2 centimeters squared. In question 6, 3 points A, B, and C are such that B is the midpoint of AC. The coordinates of A are 2, m, and the coordinates of B are n, -6, where m and n are constants. In part 1, we have to find the coordinates of C in terms of m and n. Now, it is given that B is the midpoint of AC. First, we can add the formula for the midpoint. So that is x1 plus x2 upon 2. And the y coordinate is given by y1 plus y2 upon 2. Now we know that the coordinates for A are 2, m. The coordinates of C are unknown, so we can take that as x and y. And B is the midpoint, so B is n, -6. So we can write this as n, -6 will be equals to x1 plus x2 upon 2. So we can write it as 2 plus x upon 2, comma y1 plus y2 upon 2. So that will become m plus y upon 2. Now equating the two equations, so the x coordinate is n for the midpoint, and this is given by 2 plus x upon 2. So we can write 2 plus x upon 2 is equals to n. Cross multiplying, we'll get x is equals to 2n, and this is x plus 2. So x will be equals to 2n minus 2. For the y coordinate, the midpoint of the y coordinate is -6, so we can write it as m plus y upon 2 is equals to -6. Cross multiplying, we'll get m plus y is equals to -12. So the y coordinate of C will be -12 minus m. In part 2, it says that the line y equals to x plus 1 passes through AC and is through C and is perpendicular to AB. We have to find the values of m. Now, as this line is passing through C, we can see that if the equation is y equals to x plus 1, so the coefficient of x is 1, which is the gradient, as we have our equation in the terms y equals to mx plus c. Now, if this line has a gradient of 1 and it is perpendicular to AB, so the gradient of AB will be the negative reciprocal. So if two lines are perpendicular, the gradients are negative reciprocal, which means that the gradient of AB will be -1, as the line is perpendicular and it is passing through C. And this has an equation of y equals to x plus 1, which means that the gradient is 1. So the gradient of line AB will be equals to -1. Now we can make first an equation with the gradient of AB. We know that the coordinates are 2, m and n, -6. The gradient formula is y2 minus y1 upon x2 minus x1. So we can take it as -6 minus m. So -6 minus m, y2 minus y1, and x2 minus x1 will become n minus 2. So dividing this by n minus 2, and that will be equals to -1. Cross multiplying, we'll get -n plus 2 is equals to -6 minus m. Taking the m on the left hand side, we'll get m minus n is equals to minus 6 minus 2, which is equals to minus 8. So we have the first equation over here. And to find the second equation, as we know that this line y is equals to x plus 1 is passing through C. And we know that the x coordinate of C is given by 2n minus 2. And the y coordinate is minus 12 minus m. So we can write, in place of y, we can write minus 12 minus m. And in place of x, we can write 2n minus 2. So this will become minus 12 minus m is equals to 2n minus 1. Simplifying this, taking n on the left hand side, we can write this as minus 2n minus m is equals to minus 1 plus 12. Simplifying this, we'll get minus 2n minus m is equals to positive 11. Once we have this equation now, so yes, this will become positive 11. Now we can, this is our second equation. Now we can find the values of m and n by solving these equations simultaneously. So this is m minus n is equals to minus 8. We can rearrange this to write it as minus m minus 2n is equals to 11. This will cancel out. We'll get minus 3n is equals to minus 8 plus 11. So that will be equals to positive 3. So n will be equals to minus 1. Once we have the value of n, we can find the value of m. So we can use either of the equations that we have. So m minus n is equals to minus 8. Substituting m as minus 1. So this will become m plus 1 is equals to minus 8. So m will be equals to minus 8 minus 1. So m will be equals to minus 9. So the two values, for m it will be minus 9 and for n it will be equals to minus 1. In question number 8, part 1, we have to express 4x squared plus 12x plus 10 in the form ax plus b whole squared plus c. So to express that in the form, we can first write 4x squared plus 12x plus 10 and expand the expression for ax plus b. So that will become a squared x squared. So this will become a squared x squared plus 2abx plus b squared plus c. Now to find the values of a, b, and c, we can compare the coefficients. So for x squared on the left-hand side, we have 4, and on the right-hand side, that is a squared. So a squared will be equals to 4. So a will be equals to 2. Comparing the coefficients of x, on the left-hand side, it is 12. On the right-hand side, it is 2ab. So 2ab will be equals to 12. We already know that the value of a is 2. So this will be 2 into 2 into b equals to 12. So b will be equals to 12 upon 4, which is equals to 3. And to find the value of c, we can compare the constant term. So on the left-hand side, it is 10. And on the right-hand side, that is b squared plus c equals to 10. The value of b is 3. So this will become 3 squared plus c equals to 10. So c will be equals to 10 minus 9. That will be equals to 1. Once you have the values of a, b, and c, we can write it in the form 2x plus, so it is ax plus b. So this will be 3 whole squared, and the value of c is 1. So this will become plus 1. In part 2, it says that functions f and g are both defined for x greater than 0. It is given that f of x is x squared plus 1. So f of x is given as x squared plus 1, and fg of x is given as, that is 4x squared plus 12x plus 10. We have to find g of x. Now, when we are finding fg of x, it means that in this x function, we have to substitute g of x. Now, from the previous part, we know that 4x squared plus 12x plus 10 was converted to this form. So over here, we have to substitute in place of x such a expression that when we simplify it, it will be equal to 4x squared plus 12x plus 10. So we know that expression is 2x plus 3, which means that if we write it as 2x plus 3 in place of x and whole square it and add 1 plus 1 like in the previous part, this will be equals to 4x squared plus 12x plus 10, which means that g of x will be equals to 2x plus 3, as we have to substitute in place of x 2x plus 3. So g of x will be equals to 2x plus 3. In part 3, it says find FG inverse and give the domain of FG inverse. Now, to find the inverse of a quadratic function, we should have it in the complete square form. So we can write this FG of x as 2x plus 3 whole squared plus 1. So FG is 2x plus 3 whole squared plus 1. To find the inverse function, we can first write y in place of fg, and this will become y is equals to 2x plus 3 whole squared plus 1. Now exchanging the values of x and y, this will be x is equals to 2y plus 3 whole squared plus 1. Taking 1 on the right hand side, we'll get 2y plus 3 whole squared is equals to x minus 1. Now taking the square root on both the sides, so this will become 2y plus 3 is equals to the square root of x minus 1. We'll subtract 3 on the right hand side, so this will become x minus 1 minus 3. And finally dividing the whole right hand side by 2, so this will become root x minus 1 upon 2 minus 3 upon 2. So the expression for fg inverse will be equals to square root of x minus 1 upon 2 minus 3 upon 2. We also have to find the domain. We have to find the we have to give the domain of fg inverse. Now the domain of fg inverse is basically the value of x over here, and we can figure that out from the range of the function f of x. So we know that the function f of x, if we find the range of this function, so the original function f g of x was 4x squared plus 12x plus 10. Completing the square, we got it as 2x plus, so that was 2x plus 3 whole squared plus 1. Now, as in this function, x has to be greater than 0 over here. So the range of this function will be, if we substitute x equals to 0 over here, this will become 3 squared plus 1, which is 3 squared plus 1 will become 9 plus 1, which is 10. So the range of f g of x will be greater than 10, which means that the domain of fg will be the same. So x will also be greater than 10. As we know that the range of a function is equal to the domain of the inverse function. So as the range is greater than 10, which means the domain for fg inverse will also be greater than 10. In question 9a, we have two convergent geometric progressions, P and Q, that have the same sum to infinity. The first and second terms of P are 6 and 6 comma R. So for P, the first term is 6 and the second term, so second term is 6R. The first and second terms of Q are, so the first term is 12 and the second term is minus 12R. We have to find the value of the common sum to infinity. Now the formula for sum to infinity is a upon 1 minus r. So r is given by dividing the first term by dividing two consecutive terms. So for p, the common ratio will be 6r upon 6. So the common ratio for p will be equals to r, and for q, the common ratio will be the second term divided by the first term, which will be equals to minus r. Now for forming formulas for sum to infinity for p, so sum to infinity of p will be 6 divided by 1 minus the common ratio, which is r, and the sum to infinity for q will be 12 divided by 1 minus the common ratio. In this case, this is minus r. Now, as they have the same sum to infinity, so we can write the equation as 6 upon 1 minus r is equals to 12 upon 1 plus r. Cross multiplying, we'll get 6 plus 6r is equals to 12 minus 12r. Taking 12r on the left hand side, we'll get 6r plus 12r is equals to 12 minus 6. So 18r will be equals to 6, and the value of r will be equals to 1 upon 3. Once we have the value of r as 1 upon 3, we can find the sum to infinity. So we know that the sum to infinity for p and q is equal, so we can use use a formula for p or q, either of these. So we can use 6 upon 1 minus r. So this will become 6 upon 1 minus 1 upon 3, which is equals to 6 minus 2 upon 3. That will become 18 upon 2, which is equals to 9. In part 2, it says that the first term of an arithmetic progression is cos theta and the second term is cos plus sine squared, where theta is from 0 to pi. We have to find the sum of the first 13 terms. The sum of the first 13 terms is given as 52. We have to find the possible values of theta. Now, in an arithmetic progression, if we have two consecutive terms, we can find the common difference by subtracting the two terms. So we know that the first term A is given as cos theta and the second term is given as cos plus sine squared theta. So in the first step, we can find the common difference. So that will become that will be equal to the second term minus the first term. So simplifying this, the common difference will be equal to sine squared theta. Now we know that the sum of the first 13 terms is 52. For an arithmetic progression, the sum is given by n upon 2 into 2a plus n minus 1 into d. Now the sum is 52 for the first 13 terms. So we can write in place of n, we can write 13. 2 multiplied by a, which is cos theta. So we can just write c in place of this. As we are talking about 13 terms, so this will become 13 minus 1, 12. And the common difference is sine squared theta. So cross multiplying 2 into 52. So 2 multiplied by 52 will be 104. And 104 divided by 13. So that will be equals to, so 104 divided by 13, that is equals to 8. So we'll get 8 is equals to 2 cos plus 12 sine squared. Now, as we have to find the value of theta, we can use a substitution. We know that sine squared plus cos squared is equals to 1. So sine squared can be taken as 1 minus cos squared. So we can write this equation as 8 is equals to 2 cos plus 12 into 1 minus cos squared. Simplifying this, we'll get 8 is equals to 2 cos plus 12 minus 12 cos squared. Now taking the 12 cos squared on to make it positive, so this equation will become 12 cos squared minus 2 cos. This is plus 8 and this will become a minus 12 equals to 0. Simplifying this, we'll get 12 cos squared minus 2 cos minus 4 equals to 0. And we can divide this equation by 2 to write it as, so this will become 6 cos squared minus cos minus 2 equals to 0. Factorizing this, we'll get 6 cos squared minus 4 cos plus 3 cos minus 2 equals to 0. Taking 2 cos common, this will become 3 cos minus 2. And taking 1 common over here, we'll get 3 cos minus 2 equals to 0. Simplifying, this will become 3 cos minus 2 and 2 cos plus 1 equals to 0. So cos theta will be equals to 2 upon 3 and cos theta will be equals to minus 1 upon 2. Now, as our value for theta is from 0 to pi in the question, so we can take cos in the positive and the negative quadrants as well. So as the range is from 0 to pi only, which means from 0 to 180. So cos is positive in the first quadrant. So for that, we can take we can find the basic angle. So that will be cos inverse of 2 upon 3. Substituting cos inverse of 2 upon 3 in the calculator. So that will be equals to, so cos inverse of 2 divided by 3, that is equals to 0.8410. So the basic angle is 0.8410. We can make that in the positive quadrant, which is the first quadrant. So this is 0.8410. And now taking cos inverse of half. So cos inverse of 1 upon 2. So that will be equals to 1.04. So this will be 1.047, but we'll make this in the negative quadrant of cos, as cos is negative over here. So this will be 1.047. So the first angle will be 0.8410. So we can write that x will be equals to 0.841 to 3 significant figures. And the second value will be pi minus, so this value will be pi minus 1.047. So pi minus 1.047, that will be equals to 2.0945. So the final answer we can write as x will be equals to 0.841 to 3 significant figures, and the second answer will be 2.09. So these will be the possible values of x. In question 10, a curve such that dy dx is 2x power minus half upon a plus ax power minus 3 upon 2, where a is a constant. The point A is a squared comma 3 lies on the curve. We have to find in terms of a in part 1 the equation of the tangent to the curve at a. Now to find the equation of the tangent, we need a point which is a squared minus 3 and the gradient. So the gradient is given by dy dx. The x coordinate at point A is given as x is equals to a squared. So we can substitute x is equals to a squared in place of x. So this will become 2 upon a squared into minus 1 upon 2 plus a into, so x is a squared into minus 3 upon 2. So a squared into minus 1 upon 2. So that will become 2 into, this will cancel out. So 2 into minus 1 upon 2 will become minus 1. Plus, and this 2 and 2 will cancel out, and this will become a into a to the power minus 3. So we can write this as 2 upon a squared, and this will become, so a into a minus 3 is a power minus 2. So a multiplied by a minus 3 will become a power minus 2, as this power is 1. So we can write this as 1 upon a squared. So so this is dy dx is given by 2 upon a squared plus 1 upon a squared. We can simplify to write it as 3 upon a squared, as a squared is a common denominator. Now, once we have the gradient in terms of a, we can find the equation. The equation of a line is given by y minus y1 is equals to m into x minus x1. So the y1 coordinate at point A is given as 3. The gradient is 3 upon a squared into x minus the x1 coordinate, that is a squared. Simplifying, we'll get y minus 3 is equals to 3x upon a squared, and 3 upon a squared multiplied by a squared, that will become a minus 3. Now taking 3 on the right hand side, so this will become y is equals to 3x upon a squared minus 3 plus 3. So this will cancel out, and the equation of the tangent will be 3x upon a squared. In part 2, it says we have to find the equation of the curve, and that will also be in terms of a. Now to find the equation of the curve, we'll have to integrate the expression for dy dx. So the dy dx was given as 2 upon, so that was 2 upon a x to the power minus 1 upon 2 plus ax to the power minus 3 upon 2. Now to find the equation of the curve, we'll have to integrate the expression for dy dx. So that will become y is equals to, increasing the power minus half by 1, that will become plus half, and we'll have to divide by the new power in the denominator. Increasing minus 3 upon 2 by 1, so that will become minus 1 upon 2. So minus 3 upon 2 plus 1, so that will become minus 3 plus 2 upon 2, which is minus 1 upon 2. And we'll divide by the new power, which is minus 1 upon 2, and add a constant. Simplifying this, we can write it as y is equals to, so 2 will go in the numerator, it will become 4 x to the power half upon a. This will become minus, and this 2 will go in the numerator, so this will be 2ax to the power minus half plus c. Now once we have the expression, we can find the value of c by substituting the point a, as we have to find the equation of the curve. So we know that the point A lies on the curve, and it is a squared comma 3. So in place of y, we'll write 3. In place of x, we will have a squared upon a. This will become 2a. This will be a squared to the power minus half plus c. So this will cancel, a squared and 1 upon 2 will cancel out, and so that will become a upon a. So this will be 3 is equals to 4 minus 2, and again over here, so a squared to the power minus half, that will be equals to a power minus 1, and a multiplied by a minus 1 will be equals to 1. So this will be 3 is equals to 4 minus 2 plus c, which will be 3 minus 2 is equals to c. So the value of c will be equals to 1. We can now write the equation of the curve as y is equals to 4x to the power 1 upon 2 upon a minus 2a. We can write the x in the denominator as square root of x, and the value of c is plus 1. So this will be the equation of the curve in terms of a. In part 3, it says it is now given that B 16,8 also lies on the curve. We have to find the value of A using this value and find the distance AB. Now, as this point lies on the curve 16,8, so in place of x and y in the equation, we can write 16 and 8. So in place of, we know that the point B will be 16,8. So in place of y, we can write 8 is equals to 4 into 16 to the power half upon A minus 2a upon square root of 16 plus 1. So this will be 8 is equals to 4 into 4. That will become 16 upon a minus this will become 2a upon 4 plus 1. So taking the LCM over here, we'll get 16. The LCM will become 4a. And we can take the 1 on the left-hand side as well to simplify the equation. So that will be equals to 8 minus 1, that will become 7 is equals to 16. The LCM will be 4a up here. So this will multiply by 4. So this will multiply by 4 and this will multiply by a. So this will become 2a squared. Cross multiplying, we'll get 28a is equals to 16 times 4 is 64 minus 2a squared. Bringing the 2a squared and 64 on the right hand side, we'll get 2a squared plus 28a minus 64 equals to 0. Dividing the equation by 2, this will become a squared plus 14a minus 32 is equals to 0. So factorizing this, so we have to get minus 32 when we multiply and 14 when we add. So we can get a plus 16 and a minus 2. So this will be a plus 16 and a minus 2 equals to 0. Now we have two values of a over here and we have to find the value of a, and it is saying where a is a positive constant. So as we have two values of a over here, a minus 16 and a is equals to 2. So the only value of 2 will be positive. The only value of a will be positive 2. Now, once we have the value of a, we know that the coordinates of a are a squared and 3. So that will become 2 squared, which is 4 and 3. And the coordinates of b are, so coordinates of b were given as 16 and 8. And the last part, we also had to find the distance AB. So the distance AB will be given by the formula x2 minus x1 whole squared. So that will become 16 minus 4 whole squared plus 8 minus 3 whole squared, which is equals to, so 16 minus 4 is 12. 12 squared will become 144. 8 minus 3 is 5. So 5 squared is 120 is 25. Adding these two, we'll get 169. So the distance AB will be equals to positive 13. In question 11, a curve has equation y equals kx minus 3 power minus 1 plus kx minus 3 where k is a non-zero constant. In part 1, we have to find the x coordinates of the stationary points in terms of k and determine the nature of each stationary point. Now, to find the stationary point, we'll first have to find the dy dx and then set it equals to 0. So the equation is y equals to kx minus 3 minus 1 plus kx minus 3. Finding the dy dx, so the dy dx will be equals to, we'll multiply minus 1 with the coefficient. So this will become minus 1 into kx minus 3. The power will decrease by 1, it will become a minus 2. And we also multiply it with the derivative of kx minus 3, which will be k. Differentiating kx minus 3, that will become a k. Now for stationary point, we'll set dy dx equals to 0. So this will become minus k up, and we can write it as kx minus 3 whole squared in the denominator plus k equals to 0. Taking k on the right hand side, we'll get minus k is equals to minus k upon kx minus 3 whole squared. K and k will cancel out and the negative signs will also cancel out. So we'll get kx minus 3 whole squared. When we cross multiply, that will be equals to 1. Now to find the value of x in terms of k, we'll square root both the sides. So we'll get kx minus 3 will be equals to plus minus 1. So kx minus 3 will be equals to positive 1 and kx minus 3 will be equals to negative 1. So this will become kx is equals to 4. So x value will be 4 upon k. And over here, taking 3 on the right hand side, that will become kx is equals to 2. So x will be equals to 2 upon k. Now, to find the nature of the stationary point, we'll have to differentiate the expression for dy dx and then substitute these values of k. So first finding the double derivative. So d square y upon dx square, that will be equals to multiplying -2 by -1, that will become a +2 into kx minus 3. The power will decrease by 1 and become a -3. And we'll again multiply it with so this k was already over here, and we'll multiply it with k again, so that will become k squared. So this will become k squared, and differentiating k, that will become a +1. Once we have the double derivative, now we can substitute the value of x over here. So substituting x is equals to 4 upon k over here, this will become 2 into, so this will become 2 into, in place of x, we'll have 4 upon k multiplied by k minus 3 to the power -3 multiplied by k squared plus 1. So k and k will cancel out. We'll have 4 minus 3, which is 1. So that will become 2 into 1 to the power -3 into k squared plus 1. So this will be, when we substitute 4 upon k as a value of x, we'll get a positive value over here to k squared plus 1. So as d squared y upon dx squared is greater than 0, so it will be a minimum point when x is equals to 4 upon k. Now substituting x is equals to 2 upon k, so substituting x is equals to, okay, and one correction over here, as k is a constant over here, so when we differentiate k, that will become a 0, so this will remain as 2k squared into 4x 4 into kx minus 3 to the power minus 3. Now substituting x is equals to 2 upon k into the expression, so d square y upon dx squared, so this would have become a +0 over here. So d square y upon dx squared, this will be 2 into, so that was k squared. In place of x, we'll substitute 2 upon k multiplied by k minus 3 to the power -3. So this will become 2k squared. 2 minus 3 is -1. -1 to the power -3 will be a negative answer. So this will be minus 2k squared. Now, as this is less than 0, so when d squared y upon dx squared, or the double derivative, is less than 0, it is a maximum point. So we can say it is a max when x is equals to 2 upon k. Now in part 2, it says the diagram shows part of the curve for the case when k equals to 1. We have to find the volume obtained when the region between the curve and the line is rotated through 360 degrees about the y-axis. Now the formula to find volume, so volume is equals to pi multiplied by the square of the equation and the limits b and a. So the limits in this case will be 2 and 0 as given in the question. So the limits are 2 and 0. The equation is x minus 3 power -1. So the equation is x minus 3 power -1 plus x minus 3. And we'll whole square it first and then integrate it. So to whole square this, we can treat this as an a squared plus b whole squared equation. So this will become a squared. So that will be x minus 3 power -1 whole squared plus 2 into a, which is x minus 3 power -1, into b, which is x minus 3, plus x minus 3 whole squared. Now, whole squaring this will become x minus 3 to the power -2, plus x minus 3 power -1, and x minus 3 will become 2, and this will remain as x minus 3 whole squared. Now, once we have whole squared the equation, we'll integrate this expression and then apply the limits, which are 2 and 0. So integrating x minus 3 to the power -2, we increase the power by 1, that will become a -1, and we divide it by the new power, which is -1. Integrating 2, that will become 2x. And integrating x minus 3 whole squared, that will become x minus 3 whole cube upon 3. So once we have integrated, now we can apply the limits. So the upper limit is x equals to 2. So this will become 2 minus 3 to the power -1 upon -1 plus 2 into 2 plus 2 minus 3 whole cube upon 3. And now substituting the lower limit, which is x equals to 0. So we'll subtract it from the upper limit. That will become 0 minus 3 to the power minus 1 upon minus 1 plus 2 into 0 plus 0 minus 3 whole cube upon 3. Simplifying this, we'll get this will become minus 1 upon minus 1. This will become a 1 plus 4. And this will become 2 minus 3 whole cube. So that will become 1 cube, which is 1. So this will become 1 upon 3. And we'll subtract it from the lower limit. So this will be minus 3 to the power minus 1. So we can bring it in the denominator and write it as minus 1 upon 3. And this will become plus 20, and this will become minus 27 upon 3. So simplifying this, we'll get 5 plus 1 upon 3. And this will become minus 1 upon 3. So this is, and this minus sign remains over here as this was a minus. So this will become minus 1. So minus 1 plus 4, that will become positive 3. And this will become minus 1 upon 3 and minus 27 upon 3. Opening up the brackets and simplifying this. So the final volume, when we add it up, so this will become 5 plus 1 upon 3 minus 1 upon 3 minus 27 upon 3. So that will become, when we simplify this will be 40 upon 3, and we'll add pi to the final answer. So this will become 40 pi. 40 pi upon 3 as the volume of the shaded region. Now, just for confirmation, this was minus, we can simplify this to write it as minus 1 upon x minus 3. This will be 2x over here, and this is x minus 3 whole cube upon 3. Now, when we substitute x equals to 2 over here, so that will become minus 1 upon 2 minus 3. So that would have been a plus 1. So this will become positive 5 plus 1 upon 3. And this, when we substitute x equals to 0 over here, so this will be minus 1 upon minus 3. So this would have also become a plus 1 upon 3. So this would have become a plus 1 upon 3 over here. And this is 1 upon 3 minus 9. So 5 times 3 is 15. 15 plus 1 is 16 upon 3. And this would have been 1 minus 27 upon 3. So this is 16 upon 3 minus. So this will become 1 minus 27, which is minus. So 1 minus 27 is minus 26. And one correction over here again, this would have been a negative 1 upon 3. As x was 2 over here, so this would have been a minus 1 upon 3. So this will become 1 plus 4 minus 1 upon 3. And this will be, so simplifying this would have been 14 upon 3. And this will become minus 26 upon 3. Adding these two up, we'll get 40 upon 3. And then we add pi to the final answer. So the final volume will be 40 upon 3 pi.